welcome back. Here we go. AP PreCal, this is Miss Kosh, and we are continuing 3.5, which we're doing on the same day as 3.4 and 3.1. So we're just basically introducing the idea of sine and cosine parent functions. Well, periodic, the idea of what it means to be periodic. Then we were introducing what the sine and cosine parent functions look like. We tweaked this a tiny bit to adjust and talk about amplitude and stuff, but for the most part, we're going to save those transformations for later. Okay, it says, as the input value increases, the graphs of sinusoidal functions oscillate between concave up and concave down. Remember that the points of inflection occur whenever a function changes from concave up to concave down or concave down to concave up. Okay, what are the coordinates of A? Well, it looks like we've got 0, 2, 4, 2, 8, 2. So this appears to be that midline. It goes as high as 4 and as low as 0. So the coordinates here, well, we're going 4 units, so 4 units. So this would be -4, comma, the y value for all of those is 2. Coordinates for B, well, here's -4, here's 0, here's 4, here's 8, here's 12. Okay. Notice this is arithmetic. This is kind of an arithmetic. Well, we return to that midline in an arithmetic pattern. Isn't it fun how everything works out together? It says shade the graph red. I don't have a red pen easily available, so where it's concave up, so it's going to be concave up here, and then it's concave up again here, and it's concave up again here, and it has infinitely many of those concave up places. Purple. I'm using purple. Okay. The next one, the sine function is okay, so now we're going to talk about an even versus an odd function. And if you remember, an even function is when f of negative x is equal to f of x, and it had symmetry. Like if you think about a parabola, it has like just the parent function. That's a terrible graph, but I hope you know what I mean. It reflected over the y-axis, so it has symmetry over the y-axis. That was an even function. Well, does this graph seem to do that? No, but this one sure does. So the cosine function is an even function. It has a reflective symmetry over the y-axis. And that tells us that cosine of negative x is equal to cosine of x. And if you think about this, here's the cool thing. If we jump to the unit circle, if we return to the unit circle, the x value, well, let's say we're looking at pi over 3. The x value here, which if you remember, this is the coordinate 1/2 root 3 over 2. And this one down here, this is it's the angle 5 pi over 3, but it's also negative pi over 3. If I start here, if you don't know this yet, go back and watch my other videos. We can get here by going in the positive direction to get to 5 pi over 3, or we can get here going the negative direction, negative pi over 3. But this has the same x coordinate, positive 1/2, and now it's a negative root 3 over 2. Okay, so what we know is that cosine of negative pi over 3 is equal to cosine of pi over 3. I think that's kind of cool, and you can see it right on the unit circle. Sine function, well, okay, let's talk about, if you remember, an odd function is where f of negative x is equal to negative f of x. And that had symmetry with respect to the origin. And so that meant, if you think about that, the y equals x cubed is a beautiful example of that. And so is sine. So notice this right here kind of rotates down, and it does that same sort of thing. So the sine function is an odd function, which tells us that therefore sine of x is going to, sine of negative x is going to equal negative sine of x. Let's look back at this that we drew on the unit circle. I need a new color. The sine value here is the y value. And so notice sine of pi over 3 is a positive root 3 over 2. Sine of negative pi over 3 is a negative root 3 over 2. So you could say sine of negative pi over 3 is equal to a negative sine of pi over 3, because this was a negative root 3 over 2 equals a negative root 3 over 2. I think that's pretty snazzy. So go practice. Good luck, and come back for the next video.